Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif E.g.e Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Halo kepada semua pelajar ataupun penonton kat sini. Okey, salam sejahtera kepada semua guru, ibu bapa dan pelajar-pelajar sekalian. Okey, selamat datang ke Pusat Tuisyen Akademi YouTuber dengan usaha sama E.g.e Malaysia dan juga Kelab Guru Malaysia. Okey, bermula bercuma selamanya bercuma. Cikgu memperkenalkan diri dulu. Nama cikgu ialah Cikgu Kok dari SMK Tinggi Sendiri Melaka selaku sebagai moderator pada petang ni. Okey, hari ini kami akan bersiaran secara langsung kat channel Mr. P. Siapa yang masih belum subscribe, silalah tekan butang subscribe sebagai tanda sokongan kepada Mr. P. Okey, Mr. P saya memperkenalkan dulu. Okey, Mr. P dari College Tingkatan 6 Tun Fatimah Melaka selaku presenter pada hari ini. Di kontin juga ada Cikgu Hasnita dari SMK Pakan Jaya Butterworth Pulau Pinang sebagai hari ini control host. Okay, kita akan mempelajar fizik tingkatan 5 pada petang ni. Tajuk adalah 3.3 Electromotive Force dan juga Internal Resistance DLP. Kelas ini akan berlangsung lebih kurang 1 jam. Sebelum kita nak teruskan dengan kelas, cikgu ingatkan semua pelajar dan juga penonton yang ingin menghantar komen, sila guna bahasa yang sopan dan juga gambar profil yang bersesuaian untuk tontonan umum. Okay, link e-sijil akan dibeli di hujung siaran. Link e-sijil dapat diisi boleh menggunakan email e.g.e, MOEDL, MOE My Guru dan juga email Jawi. Cikgu yang, cikgu akan berikan kod di sepanjang kelas ni untuk pelajar tebuskan mata kredit AYU. Link rekod kredit pelajar juga akan dibeli tapi di hujung siaran nanti. Okey, sila fokus kepada isi belajar yang akan disampaikan oleh Mr. P. Semoga kelas kita pada petang ni dapat dimanfaatkan sepenuhnya oleh para pelajar. Baiklah, cikgu berikan kod dululah. Okey, kod yang pertama iaitu A3. A3. Okey, dengan ni cikgu serahkan kelas ni kepada Mr. P. Dipersilakan Mr. P.
Okey, so terima kasih kepada Cikgu Kok selaku moderator hari ini. Okey, so saya Mr. P kini mengajar di College Tingkatan 6 Tun Fatimah Melaka. Untuk pengetahuan anda, so kelas Tuition Percuma Fizik SPN untuk AYU, program AYU ini ada 2, iaitu tingkatan 4 diadakan pada setiap Jumaat 9:30 malam. Dan kini kita sudah sampai subtitle Hukum Kepler dan disampaikan oleh Cikgu Rosmawati. Okay, so siapa yang belum lagi attend kelas tersebut bolehlah visit channel Cikgu Rosmawati. Dan hari ini kita ada kelas tingkatan 5 seperti biasa pada pukul 2 petang dan hari ini cikgu akan sampaikan subtitle 3.3 Electromotive Force and Internal Resistance. So ini merupakan panitia fizik AYU SPN yang banyak memberi sumbangan kepada subjek fizik ini. So pada petang ini bersama saya di konti ada Cikgu Kok dan juga Cikgu Hasnita. Terima kasih bersama saya pada petang ini. Okay, so we will continue our lesson, okay, for chapter 3, electricity. The subtitle, as mentioned just now, that is Electromotive Force and Internal Resistance, iaitu daya gerak elektrik dan rintangan dalam untuk bahasa Melayu. Okay, so for today's lesson, there are total about 4 learning standards you are going to learn. So for learning standard 1, you have to know how to define the electromotive force. So what is the electromotive force? So this is the definition. So electromotive force, or we can know as E.M.F with the symbol sigma, okay, is the work done by an electrical source to move one column of charge in a complete circuit. So that the formula we use for the E.M.F or electromotive force will be E, where there is the energy or work done, over the total charge. Okay, so for the electrical source, here we're referring to the battery. To keep the current to flow through the conductor, there must be a force pushing the charge through the conductor. So the force we know as E.M.F. But the E.M.F is actually not a force. It has the SI unit with volt or joule per coulomb, which is same as the potential difference. Okay, but there is a difference between potential difference with the electromotive force. Okay, so you can look at the battery, which is labeled as 1.5 volt. So it is show that the 1.5 label on dry cell is actually means by 1.5 joule of electrical energy supplied if one column of the charge flow around a complete circuit. So this is the meanings for the 1.5 volt label on the dry cell. Okay, so let us see what is the difference between the E.M.F and the potential difference. So where they have the similarity for the SI unit, which is volt. Okay, so here, as we measure for the E.M.F, we're using the voltmeter because the SI unit is volt. So the apparatus we use to measure E.M.F or together with the potential difference will be voltmeter lah. Okay. So from the figure, you can see that we measure the voltmeter. We measure the reading of the E.M.F when the switch is open. So the reading at the voltmeter is actually we know as the E.M.F. Okay. So and from this figure, you can see the dry cell is actually have 1.5 volt. So that means that the E.M.F here will be have the same reading with the volt label on the dry cell, which is 1.5 here. As the switch is open, so there is no current flow through the external circuit. Okay, so here is the external circuit. Okay, therefore, the bulb is not light up in the case of the E.M.F. So we can say that, okay, there is no current flow through the circuit. The voltmeter is 1.5 volt when the circuit is open, okay? So the switch is open. So E.M.F, the reading of the voltmeter, which is connected directly across the terminal of the cell. So the E.M.F, we also will give the value as 1.5, which is same as the value of the volt label at the dry cell here. Okay, so the definition will be the E.M.F is the work done by a source of electrical energy. Here will be the battery lah, in driving one column of charge around a complete circuit. And here, when we talk about the potential difference, the reading of voltmeter here will be reading of potential difference when the switch is closed. Okay, so when the switch is closed, there is the current flow at the external circuit here. Okay, so the voltmeter measuring the potential difference across the bulb here and not the E.M.F again for this situation. Okay, so the reading of the voltmeter will be expected lower than 1.5. So that means there is a voltage drop when we close the switch. Okay, so as we close the switch and the circuit is complete, so the current will be flow through the external circuit here and the bulb will be light up. Okay, so this is a different you can see at the E.M.F and the potential difference. Okay, so as mentioned, when the switch is closed, the circuit will be complete. So the current will be flowing through the circuit. And the reading will be less than 1.5 because now we measure the voltage across the bulb already. So we can say that here there is a voltage drop when the switch is closed. So if the voltmeter reading is 1.2, so we just assume that our reading here is less than 1.5, which is 1.2 here. Okay, so the potential difference across the lamp will be 1.2. So the voltage drop will be 1.5, which is the E.M.F or the voltage label at the dry cell. Okay, minus the 1.2, which the potential difference across the lamp when the switch is closed. So we see that that is about 0.3 of the voltage drop here. Okay, so we can conclude that the value where 1.5 is the E.M.F minus the potential difference will be 0.3. Okay, so we know as voltage drop, and with the formula of I times R. So I will be current flow in the circuit, R will be the internal resistance. Okay, so potential difference is the work done to transfer one column of charge between 2 points in the complete circuit. So the here main difference will be the 2 point where is the potential difference across the lamp here. Okay, so let us go to our first question today's. Okay, so diagram shows a circuit containing a dry cell and resistor. Dry cell will be here. Okay, resistor will be the bulb. So the dry cell has internal resistance, which is labeled as small letter R, and the electromotive force, E.M.F, which is 1.5. So that means the dry cell is labeled as 1.5. What is the voltmeter reading when the switch is on? So you can see when the switch is on, so that means that the current will be flow through the external circuit. And there will be a internal resistance acting at the dry cell and cause the voltage drop. Okay, so we expected the reading will be less than E.M.F. So that means here will be less than 1.5 volt. So answer will be B. Okay. Okay, so the next question here. So what is the electromotive force? So the tips here will be the formula where E over Q. So E is actually the work done by the source of energy to driving one column of the charge in the complete circuit. Okay, so you can look at the A, the work done by charge in a circuit. So the definition is not complete. Okay, because the work done is done by a source of energy to driving a column or charge. Okay, so here not mention any source of energy, so it's wrong. The second B also the wrong because the work done is done by the source of energy. Okay, so it's also wrong. Then the C, the work done by a source of energy in driving a charge around complete circuit. So here, the message here is not a charge, but answer D will be one column of charge. Okay, so the answer here will be D lah. Okay, so the next question number 3, which circuit is used to determine the electromotive force E.M.F of a dry cell? So this is a question in SPM 2013 and 19. Okay, so to measure E.M.F, switch must be open. Okay, and then the E.M.F we measure with voltmeter. So for A, you can see the connection is to ammeter. Okay, so we measure the EMF with voltmeter, but not ammeter, so A is wrong. Okay, so the answer, you can see the B is correct because the connection to the circuit is with parallel when we measure with voltmeter. So the answer is actually B here. So we see why the C is wrong. So here, because the connection for the voltmeter to the circuit must be parallel, but here is series. Okay, so C will be wrong. And then D, we measure the EMF by using the voltmeter, not ammeter. So D also will be wrong. So the answer is B lah. Okay. Okay, so the next learning standard will be explain what is the internal resistance with the symbol of a small letter R. Okay, so internal resistance in a dry cell is defined as resistance that caused by the electrolyte in the dry cell. So that means the internal resistance is also a resistance, so with the unit of ohm also lah. Okay, so what is means by the electrolyte? Because here the definition mentioned that the internal resistance is a resistance caused by the electrolyte. Okay, so here you can look at the general structure of the dry cell or battery. So there are two terminal, which is anode and cathode. And the reaction is a chemical reaction in the electrolyte here. So the common electrolyte used in the battery will be the ammonium chloride. Okay, so electrolyte is actually serve as a catalyst to make a battery conductive. Okay, so that means the electrolyte able to change the chemical energy to electrical energy here by promoting the movement of the ion. Okay, from the cathode to the anode on charge or reverse when they discharge lah. Okay, so chemical reaction take place here will cause the internal resistance occur. Okay, in the dry cell. Okay, when the circuit is when the switch is closed lah. Okay, so the internal resistance will be cause the energy loss in the dry cell due to the work done to drive the charge of one column against the resistance of the electrolyte. And then second, will cause the voltage drop when the current flow to the closed circuit. Okay, which potential difference across the cell will be lower than EMF. Okay, so we can conclude that the internal resistance will cause the loss of the energy in terms of heat. Okay, so you can touch the battery, you can feel the heat. Okay, when the reaction, chemical reaction, it takes place. Okay, and the next will be the voltage drop. Okay, so that means here we have a formula, common formula will be used in this subtitle. Okay, where the voltage drop will be equal to I times R. Okay, the I here will be the current flow in the circuit. The R will be the internal resistance, where will be equal to the EMF minus the potential difference. Okay, so as mentioned, the internal resistance is also the resistance produced caused by the chemical reaction in the electrolyte of the dry cell. Okay, so the resistance, internal resistance will be have the same SI unit with the common resistance we know, which is the ohm lah. Okay, so in this subtitle, we have few important equation where relating the EMF, V, I, and R. Okay, so from what we have already know that when the circuit is closed, there will be a voltage drop, okay, caused by the internal resistance. So the formula will be IR equal to EMF minus V, as mentioned just now. Okay, So here you can see the idea is come from the circuit when the switch is closed here. Okay, so from this formula, we rearrange the formula of the voltage drop. Okay, so we get this, where we move the volt become positive lah. So this is a first equation we'll use. And then from the Ohm's law, where V equal to IR, okay, so we substitute the V become IR, okay? So the R will be the resistance of the buck here. So we get another equation will be IR plus IR. So the capital R will be represent the resistance at the external circuit where come from the buck or resistor. And then the small letter R will be the internal resistance in the dry cell. Okay. Okay, so the checkpoint here will be the question regarding the application of the formula we derived just now. Okay, so the first question here will be the question in 2010. So let us read the question together here. A cell has an E.M.F of 1.5 volt when it's connected to an external resistor. The potential difference is 1.3 volt and the current flow will be 0.2 ampere. So what is the value of the internal resistance? So the question will be asked the small letter R here lah. Okay, and then given that the first, the E.M.F will be 1.5 volt. Okay, and then the potential difference V will be 1.3 and the current here is equal to I equal to 0.2. Okay, so from this formula, voltage drop, okay, so we can substitute the value we get. So I equal to 0.2, R we want to get, okay, the value for internal resistance, and 1.5 minus 1.3. So we get the internal resistance here will be 1.0. So the answer will be B. Okay. Okay, so the next will be question 5. So let us read the question together. This is the question in SPM 2014. So diagram show an electric circuit. Okay, so this is an electric circuit. When the switch is off, the voltmeter reading is 9.0. Okay, 9.0. The internal circuit given will be 1 ohm. So what is the reading when the switch is on? So the switch is on, that means we close the switch here lah. So we want to find what's the value of I flowing at the external circuit here. Okay, so from here we know that the when the switch is off, that means the reading of voltmeter is actually given us the value of E.M.F. Okay, and the internal resistance is straightforward. The question give as 1 ohm already. Okay, and then here we get another information from the figure where the resistance for the buck is 2 ohms. So again, we're using the formula we learned just now at Learning Standard 2. Okay, so we rearrange, we factorize out the I here, we get this. And then we substitute all the value given, 9 for E.M.F, 2 for the resistance, 1 for the internal resistance. So we get our I will be 3. So answer will be A. Okay. Okay, so the question number 6 is the question in SPM 2017. Okay, so diagram show a dry cell connected to a buck. Okay, here. And the current flow through it is 0.5 ampere. So the current here will be 0.5. So what is the potential difference across the bar? So the question want to ask us, what is the value for potential difference? V. Okay, so here I is given 0.5 already. And then from the figure, this is a value for E.M.F, which is 9. And the internal resistance will be 0.4 in the figure here. Okay, so we're using this formula. Okay, we substitute E.M.F as 9. Then I equal to 0.5 given by the question, and R 0.4. Okay, so we use 9 minus 0.2. We get 7. So the answer will be C. Okay, so you can see the question asked actually is not difficult lah, okay, in the SPM. Okay, so the next, determine the E.M.F from the Y-intercept and the internal resistance from the gradients of the graph. Okay, just now we determine our value of E.M.F R by using the equation. Okay, then now we need to find the value of E.M.F and R through the graph line. Okay, so here you can see we using the voltage drop formula here to start our definition of the voltage drop and also the equation. So for graph, we also can start with the same formula here. Okay, so we rearrange the formula. We get the new equation will be like this. Okay, so where we move V to another side, and then we move IR to the right side. Okay, so we get negative IR here. Okay, so why we rearrange like this? Because we want to plot a graph where the Y will be V, the X will be I. Okay, so this is the straight line. Mathematics knowledge, actually you learned already at your PT3. So Y equal to MS plus C. Okay, so here we want to plot the graph V against I. Okay, this is the first. So the graph will be show like this lah. Okay, later on the next learning standard, we'll see why the graph will be like this lah. Okay, so this is the first. We plot the graph V against I. And then the second, from the equation, we know that the M is actually the gradients of the graph will be the value of minus R. Okay, so the minus R will be the internal resistance. Okay, the internal resistance value will be positive actually. Okay, so this is the second. And then the third. Okay, so why we see the gradients of the graph will be negative? Okay, this is because the gradients of the graph showing that the value of V is always less than the value of E.M.F. So here, the E.M.F value is the maximum when the current is 0. So that means this is the condition where the switch is open. When the switch is closed, so the current will be increased, will be flow through the circuit. For example, here may be 0.2. So you can see the value for V is less than the E.M.F already, because the voltage drop occur when the internal resistance exists in the dry cell. Okay, and then here the C will be the intercept Y, which is the value of E.M.F. Okay, so this is the info you can get from the graph. So that means that when I equal to 0, so I already mentioned just now. Okay, so here, so the value of the V will be equal to E.M.F. Okay, so this shows that when there is no current flow, the potential difference across the cell is E.M.F. Okay, so now we discuss the question regarding the graph. So diagram 2.25.1 here show an electric circuit to determine the electromotive force, E.M.F, and the internal resistance of the drive cell. Okay, this one is the electric circuit, and then the diagram 21.2 shows the result of a graph of the potential difference against I. Okay, so E.M.F could be determined from, so where is the E.M.F? So from here, the equation we derived, okay, just now. So we know that the R is determined through the gradients of the graph, and the E.M.F we get from the intercept Y. So the intercept Y, that means will be here lah. So the value will be V intercept. So the answer will be A. Okay, so this is the question example for section A. So diagram 3.1a shows an electric circuit connected to a new battery. So this is the electric circuit which is connected to new battery. Okay, so the 3.1b shows the potential difference and current graph for the new battery lah. Okay, for the new battery here, 1.5. Okay, and then the second diagram 3.2a. Okay, and electric circuit connected to all batteries. So that means the battery here is also 1.5V, but is the all battery. Okay, so diagram 3.2b show the potential difference current graph of the electric circuit. So that means what you can observe that the gradients of the graph is different. Okay, so from here you can see the gradients for the graph 3.2b is greater than 3.1b. Okay, so as mentioned just now, the gradients represent the internal resistance. So that means that the all battery will have the higher internal resistance compared to the new battery lah. Okay, so let us see what the question asks. So the first, what is the physical quantity represented by the Y-intercept? So the Y-intercept will be electromotive force. So that means it will be volt lah. Okay, so here is the E.M.F. Okay, so physical quantity, the answer here is E.M.F lah. Okay, and then the B, based on the diagram 3.1a, okay, this diagram, and 3.2a, compare the reading of voltmeter. So the voltmeter will be here lah. Okay, so you can see the reading of the voltmeter in diagram 3.1a is greater than 3.2a. Okay, and then the next question, compare the brightness of the bulb. So the bulb, you can see here, for 3.1a is brighter than 3.2a. So the answer, 3.1a is greater than 3.2a here. Okay, so the next question, state the relationship between the reading of the voltmeter and the brightness of the bulb. Okay, so here the voltmeter will be here. The brightness will be of the bulb will be here. So the reading of the voltmeter increases, the brightness will be increases. Okay, so the higher the reading of voltmeter, the higher the brightness of the bulb. So this is what we can get from the figure actually. Okay, so for C, based on the diagram 3.1b here and 3.2b here, these two diagrams, state the physical quantity represented by the gradients of the graph. So as mentioned, here is an internal resistance. Okay, from what we already learned in the explanation regarding the graph just now. Okay, so the gradients of the graph will be internal resistance. Okay, so the next question, compare the gradients. So just now I already explained. Okay, so the gradients for 3.2b is greater than 3.1b lah. Or you can see the gradients for the 3.1b is less stepper compared to 3.2b here. So that means the gradients for 3.1b is smaller than 3.2b. Okay, so make a deduction relating the answer in 3C2, okay, this, and the reading of the voltmeter. Okay, so here, that means the gradients greater, the voltmeter reading will be smaller, or vice versa. Okay, so here you can see the voltmeter reading is higher, the graph, gradients of the graph will be smaller. So the smaller the gradients of the graph, the higher the reading of voltmeter. Okay, so this is the question can be asked at section A regarding the graph. Okay, so we go to our learning standard 3, conduct experiment to determine E.M.F and the internal resistance in a dry cell. Okay, so the aim of the experiment is to determine the electromotive force, E.M.F, and internal resistance of cell. So hypothesis, when the current I increases, the energy being dissipated increases. So, and cause the potential difference decreases. So that's why just now we saw the graph. Okay, so we saw the graph will be have the decrease of the gradients will be like this just now. V against I. Okay, because the I increases will cause the energy dissipated increases. So the potential difference decreases. So the manipulated variable here will be the current. So that means you can see this is a connection for this experiment, okay, where we connect ammeter series with others component except the voltmeter. Okay, so the voltmeter will connect parallelly. Okay, so and responding variable here will be the potential difference across the cell. So this is a reading of the voltmeter. So the constant variable here will be a temperature of wire. So that means to avoid the changes of the temperature, so the switch must be open when we already take the reading. Okay, so this is try to maintain the temperature and minimize the changes between the responding variable. Okay, so the apparatus used will be dry cell, switch, voltmeter, ammeter, rheostat, and connecting wire. So the arrangement, as mentioned, will be like this. So when you draw, your answer can be in the symbol at your paper 3 here. Okay, so as mentioned, the ammeter will be connected to all others components besides the voltmeters in series, and the voltmeter will be connected to the circuit parallelly. So procedure, Okay, so when you write the procedure in your paper 3 first, after you draw the arrangement of the apparatus, you just give the sentence like this lah. The electric circuit set out as shown in diagram. Okay, and then the switch is closed and the reading of ammeter I equal to 0.2A and the voltmeter recording by adjusted the rheostat. So you must give your first manipulator variable and then record your first RV here lah. Okay, so that means you have to adjust your rheostat here to ensure that your first reading of your manipulator variable will be I equal to 0.2. Okay, so how to adjust? You can see my others video in my channel. Okay, and second, you have to give others repeated reading for your manipulator variable. Okay, so minimum we have total 5 manipulated variable. Okay, so here will be 0.4, 0.6, 0.8, and 1.0. Okay, so then you have to record your reading of voltmeter also lah. Okay, but here I missed out already, so you have to add on lah. Okay, so record the reading of voltmeter respectively lah. Okay, so you must mention your MV and you have to also mention your RV where you have to measure the reading of the voltmeter here. Okay, so that means here will be the procedure you have to write if your paper 3 gives the question with tidak berbantu lah. Okay, so the tabulation will be like this. So here will be the reading for our manipulator variable, which is already given. It's the reading for the ammeter we need to adjust to accordingly by using the rheostat. Okay, so the first reading mentioned at the procedure already will be 0.2, 0.4, 0.6, 0.8, and 1.0. Okay, in your table, you must give symbol of the parameter. Current here will be I and the unit as I. Okay, so here will be symbol. Here will be the unit as I. Okay, and then after we adjust our rheostat so that our first reading becomes 0.2 ampere, so you have to take your reading of the responding here, which is at the voltmeter. Okay, so here the first reading I just give lah, okay, 2.7. And then for second reading, we adjust our rheostat so that our current becomes 0.4 ampere. So we expected the reading of our voltmeter will be reduced. Okay, so we get 2.5 and then 0.6 we expected lower than 0.4, which is here I give 2.3 and others will be 1.9 and 1.7. So as mentioned just now, why the potential different across the cell will be decreased, because the energy dissipated is become more when the current flowing through the circuit increase lah. Okay, so we have to plot the graph. Okay, so first will be V against I. So for the graph, you also have to give unit and the symbol. So the symbol is here, and the unit will be here. Okay, and then we have to give the suitable value for our axis X and Y. So normally we will give 1 unit to 1, to 2, to 5, or to 10. So here will be 1 to 1, okay, for the Y-axis. For the S-axis here will be 1 to 0.2. So that means 1 to 2, the ratio. Okay, so we have to choose suitable scale for x-axis and y-axis here. Okay, so the first reading will be 0.2 here, and 2.7 is about here. So we get our first point. Okay, and then second, 0.4 and 2.5 will be here. Okay, actually it's here, 2.5. Okay, and others lah. Then we have to plot a straight line. Will be like this. So the best line, that means that the point of the graph will be at bottom or above the line lah. Okay, so this one is considered as a best line. Okay, so to get our value of E.M.F, we have to get our Y-intercept here. So we have to extrapolate our graph, okay, until we meet the vertical axis here. Okay, so we get our value will be 3.1 volt here. Okay, then second, we have to get from our experiment is we want to get our internal resistance here. So there will be gradients, the gradients of the graph. Okay, so the gradients will be negative R. So we have to choose the biggest triangle and mark as triangle here. So we choose this point, which is 0, 3.1, and we choose this point where 1 and 1.7. Okay, so we substitute in the formula of gradients where we learned already in our Form 3 mathematics, y1 minus y2 equal to s1 minus s2 will be this. So we get negative R equal to negative 1.4. So the value, our internal resistance for the battery in this experiment with this value will be 1.5 ohm. Okay, so this is a discussion for the experiment. Okay, so Bangkok, we can take a break.
Okay, pelajar dah dengar banyak kan dengan ilmu-ilmu yang disampaikan oleh Cikgu P. Okay, sebelum iklan, saya nak bagi 2 kod lagi untuk belajar tepuskan kredit nanti kan. Okay, kod yang kedua adalah 10. 10. Okay, jangan ke mana-mana, nanti kembali selepas ni.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma, mestilah Akademi YouTuber.
Okey, baiklah. Jom kami teruskan bersama dengan Mr. P. Dipersilakan Cikgu.
Okay, thank you, Cikgu Kok. Okay, so we go to our last learning standard here. Solve problem involving E.M.F and internal resistance in a dry cell. Okay, so first, compare the arrangement of battery in series and in parallel. Okay, so in PD3 level, we always compare the arrangement of the resistor in series and in parallel. So we seldom to have the comparison between the arrangement of battery in series and parallel. Okay, so let us discuss what is the effect of the arrangement of the battery to the overall value of effective voltage E.M.F lah, okay, and the effective internal resistance. Okay, so from here you can see when we have the arrangement of the battery in series. Okay, so the current will be equal. That means the current, if I say here, I go to our first battery I1, and then go to second battery I2, third I3. So that means all will have the same value of the current. Okay, and then the second, the total voltage, okay, when like this example, so the total voltage supply to the circuit will be 1.5 times 4 lah, for this case. So it will be 6.0. So that means that for the battery arranged in series, they will be provide a higher E.M.F lah. Okay, and then the effective internal resistance will be also increased actually. You can see the RT is actually here is effective internal resistance. Okay, later on I will use simple RE lah. Okay, so you can see we have to add on all the resistance. So that means the internal resistance will be increased also lah, when we arrange our batteries in series. And the second, if we arrange our battery in parallel, the current will remain the same. For example, current come from here, right? Okay, so the current I1, I2, I3, I4 all together will be the total current flow out. And then the second, the value of potential difference, they will be maintained the same. So that means if, let's say, we connect our battery in parallel, so the voltage supply or the E.M.F is actually same, 1.5 only lah. Okay, so this is the impact of the arrangement of battery in parallel. So that means you add on how many battery that is not affected to your total E.M.F supply, or the effective E.M.F will be always the same. Okay, and the effective internal resistance will be using this formula lah, which is we learned already in the effective resistor. Okay, resistance we learned at PT3, and also the section 3.2. Okay, so here we can see that the overall effective internal resistance will be decreased if we arrange our battery in parallel. Okay, so this is the info you need to know before you go to the problem solving question. Okay, so let us go to our first question regarding the learning standard 4. Okay, so here diagram 7.1 shows the circuit with the dry cell arranged in series. Okay, you can see the dry cell is arranged in series. And 7.2, the dry cell is arranged in parallel. So the dry cell here is 2 volt each, and the internal resistance is 0.5 for each dry cell here. Okay, so this is the thing you have to know. There is actually same battery value, and the internal resistance is also the same. Okay, and then here you can see the others value given here. The resistance for the bulk will be also the same. Okay, so this is the value given by the question. And the first question, compare the current flow in the two circuits here. Which arrangement of the dry cell give greater current? Explain. Okay, so this is the value given. Just now we already explained. Okay, so we need to find what is the effective internal resistance here for the arrangement. 7.1 and 7.2 is different. And the second difference here will be the effective E.M.F will be also different because the arrangement of the battery is different. Okay, in the case of the arrangement of dry cell in series, which is in diagram 7.1, okay, so the internal resistance effective will be 0.5 plus 0.5 will be 1.0. So that means the effective internal resistance is increased now. Okay, the effective E.M.F also increased. 2 plus 2 will be 4. Okay, the external circuit, the arrangement is the same actually. So we just want to know the impact of the arrangement of battery, okay, to the overall value we want to get lah. Okay, so we want to get the current. So we use this formula we learned already in the learning standard 2. Okay, we rearrange, become like this. And then I, we get this lah. So we apply this formula. Okay, so we substitute 4 and 1.0 to our E. And the R will be 4 lah, given by the question. So we get our value is 0.8 ampere. Okay, and then the arrangement of the dry cell in parallel will be like this, diagram 7.2. Okay, so we have to get the value of I also lah, requested by the question. Okay, so that means we use this formula lah. Okay, but the effective internal resistance and the effective E.M.F is different for diagram 7.2. Okay, so for the effective internal resistance, we're using formula like this lah. 1 over 0.5 plus 1 over 0.5. Okay, so we get our internal resistance. Effective will be 0.25. You can see decrease lah. Okay, and for the effective E.M.F will be remain the same as the battery arranged in parallel. Okay, you can see the difference, right? Okay, so what's the impact for current? So the current will be decreased compared to arrangement in series. So that means that the effective E.M.F impact is actually greater than the effective internal resistance. Although you can see the internal resistance is lower when we arrange parallelly, but the overall effective E.M.F actually you also decrease many lah. Okay, so here the discussion here will be the dry cell connected in series provide higher current because of the higher effective E.M.F lah. So here we have to discuss the higher value of E.M.F given when we arrange in series lah. Okay. Okay, then the B, if the circuit in diagram 7.2 is replaced with 3 dry cells in parallel, current, calculate the current. So that means, as per explanation just now, when we arrange the battery parallel, so the current will be smaller. Okay, as per discussion for A lah. So let us see here, the diagram 7.2 here. You can see we have to add on one more battery. Will be 3 battery lah, 1, 2, 3. So what is the impact for the current? Okay, so this is arranged in parallel. So the effective resistance 0.167. Okay, so will be 2 volt for the effective E.M.F because we arrange parallelly. Okay, so we get the value of the current increase. So that means if we compare the same connection, which is parallel, so when we add on more battery parallelly, so the current will be increased because of the effective internal resistance decrease. But if let's say we compare to connection parallel with series with the same amount of the battery, the series connection of the battery given higher value of current. Okay, so this is due to the impact of the E.M.F effective is greater. Okay, okay, so compare the current arrangement of the 2 dry cell parallel and 3 dry cell in parallel. So as per mentioned just now, the current we get in 3 dry cell in parallel will be higher lah, which is 0.48. For the parallel in 2 dry cell is 0.47. We get already just now. Okay, so the current in 3 dry cell arranged in parallel is higher. Why? So you can see what we get when the numbers of dry cell increase, the current we get increase. Explain the reason. Okay, so when numbers of dry cell in parallel increases, the current in the circuit increases because of the effective internal resistance decreases. Okay, so that means in this example, we can conclude that when we discuss the current comparison between the dry cell arranged in series and parallel, the dry cell arranged in series will have a higher value of current due to it have the higher effective E.M.F. But if we discuss regarding the numbers of dry cell arranged in parallel, the greater numbers of the dry cell arranged in parallel will be given higher current value. This is due to when the dry cell arranged in parallel increase the numbers of battery, so the effective internal resistance decreases. Okay. Okay, so the next question will be question number 10, which is in the year of 2018. So diagram shows an electrical circuit if an identical dry cell is connected in parallel. So one more. Okay, what is your expected? So as per mentioned just now, when the battery is connected in parallel, so overall E.M.F will be maintained the same. Okay, but the overall effectiveness of the internal resistance will be decreased. So current will be increased, right? Okay, so this is the equation we can use to explain this situation. Okay, so the effective E.M.F same, then the effective internal resistance decrease. So the current will be increased. So the first A will be wrong already. Okay, because the current here is actually increased, so wrong. And then the power is not related. You can see from the formula. Then the C, the brightness of the bulb is increases actually because the current flow increases. Okay, so will be wrong also. So the answer here, the total internal resistance of dry cell decreases. So answer is D. Okay, so we go to our question 11. Okay, so this is an example question. Okay, at section C. So diagram show 4 circuit W, X, Y, and Z containing 3 dry cell of electromotive force, E.M.F 1.5 V. So that means the battery here all will be the same, 1.5 volt. 2 bulbs label 2 volt, 0.5 watt. Here we have two bulb here with same power and the voltage needed. Okay, the resistor will be all the same, 10 ohms. So you are required to determine the more suitable circuit that can be used to light up the bulb with normal brightness. You may need to do some calculation. Study the specification of all the 4 circuits based on the following aspect. Okay, so we need to have the same brightness. Okay, for the requirement for this question. Okay, so the aspect you have to discuss first, the type of connection of the dry cell. So from this circuit here, you can see the dry cell is connected in parallel for the circuit W and series for circuit X, Y, and Z here. So which we need to choose. So here we have to observe for the connection parallelly for the battery. So the E.M.F effective will be less than 2. So why we need to mention 2? This is because the, okay, so here will be 4.5 lah. Okay, because you can see the bulb, the requirement voltage supply to light out the bulb with normal brightness will be 2 volt. So here the circuit W is not meet the minimum E.M.F needed, which is here less than 2, is only 1.5. So that means here for the circuit X, Y, and Z, we get the minimum 2 voltage needed for the bulb already. So that means we have to choose the connections of the cell must be in series, okay, to produce higher voltage. Okay, or you can mention to produce 4.5 volt E.M.F also can. Okay, then the second, the connection of the terminal of the dry cell here must be positive terminal to negative. This is a common knowledge. The battery positive here and here negative. We must connect to another battery positive and negative here, right? So that means here the positive terminal of battery will be connect to the negative terminal of the battery so that the current will be able to flow. Okay, so this is the second. Okay, for the third, to the connection between the resistor and the bulb. Okay, so here we have 2 conditions also. So here is connected in series, and here we connected in parallel. Okay. Okay, so for this question, some of the students will be give the answer where the resistors should be connected in parallel, so that the resistance will be lower, right? So the current flowing will be higher. So, but here the answer is wrong. If I say you keep the resistor connect in parallel, you should connect with series. Okay. Why? This is because you can see that, as mentioned just now, the overall effective E.M.F for this circuit is 4.5. But the bulb needed is only 2 volt. And the question requests that the brightness must be in normal. So if I say we maintaining given the voltage supply which is higher than 2 volt, so that means the bulb will be light up brighter and maybe will be burned in shorter time. Okay, so in this case, we have to choose connect with series okay, to adjust the potential difference across the bulb to 2 volt. So we can actually check whether with the resistance value of 10, so the potential across the bulb here will be 2 or not. So we can calculate by this formula. Power equal to V square over R. So the resistance for the bulb here will be V square divided by power. So we get here is actually 8 ohm. So the resistance for the bulb is 8 ohm. So what is the voltage across the bulb here? So we're using this formula. Okay, so 8 divided by total resistance here, and then multiply with the total E.M.F. So we get is 2 volt. So that means with the resistor which is connected in series, so we will get our value of the potential difference across the bulb. Here is 2. So the bulb will be bright at the normal brightness. Okay, so here we must choose series Okay, and then the type of the connection for the bulb. So here we also got 2, parallel or series. So here we must choose parallel, so that if one bulb is blown, the other bulb is not affected. Okay, so from here we have to choose X okay, to meet the requirement for this question. Okay, so as many discussion already, this must be this is encourage you to do in the table. So the first, connect the dry cell in series. Okay, so that we can get higher voltage supply, which is minimum we need 2 volt lah. Okay, so here is not meet as per explanation just now. Second, the positive terminal of dry cell is connected to the negative terminal of the cell to let the current flow in the circuit. Then the third, the resistor is connected in series lah. As per mentioned just now, we want to adjust the potential difference across the bulb to 2 volt so that the bulb can light up with the normal brightness lah. Okay, and then the bulb is connected in parallel. So if one bulb is blown, the other bulb still light up. So we'll choose X circuit. Okay, then we just copy these 4 aspects as our mark number 10. Okay. Okay, so C, diagram 12.3 shows an electric circuit. Okay, so the E.M.F of the cell is 2. So it's given as 2 volt. And then the internal resistance is 1. And the resistor, we have 2. R1, 5, R2 is 12. Okay, so for the first question, calculate the reading of the ammeter. So we want to get the value of I. Okay, when only switch 1 is on. So that means we just close here. So the current will be flow here only lah. So the effective resistance will be only 1 lah, R1. Okay, so we apply this formula, we rearrange, we get this, we substitute all the value given. So we get our I is equal to 0.33. Okay, so please left your answer in minimum 2 decimal places, and we correct unit here. Okay, and then the next will be both switches S1 and S2 is on. So we close here and close here. So that means the main difference will be the effective resistance will be different here. Okay, so the E.M.F will be the same 2 volt. The internal resistance is also the same, given by the question is 1. The difference here is the effective resistance will be 1/5 plus 1/12, since they are connected in parallel. Okay. Okay, so we get our our effective resistance. Okay, effective resistance here will be 60/17. And we using the same formula, we substitute E.M.F as 2, resistance 60/17, internal resistance 1. So we get our answer in 0.44 ampere. Okay, so you'll get 3 marks lah. First mark will be this lah. Second will be correct substitution. Third will be answer with minimum 2 decimal places and correct unit. Okay, so the last we have some information regarding the connecting solar cell and the battery in the electric car. Okay, so solar cell are photovoltaic cell. They can transform light energy directly into the electrical energy. So you can see here is a common application of the solar cell panel in the water heater in our home. Okay. Okay, so the photovoltaic cell is made of semiconductor material, usually silicon. Okay, so the photovoltaic effect can generate electricity when the surface of the cell is exposed to light. Okay, so this is an application of solar cell, which is commonly used in, as mentioned just now, we use in the water heater in our home, right? Okay, so but now it's actually widely used in others application. Okay, so what is the photovoltaic effect? here. So you can see the first solar cell are composed of 2 layers of the semiconductor material with opposite charges here. So you can see here is actually related to the N-type silicon and P-type silicon. So the opposite charges here is actually the N-type silicon, referring to more of the free electron. So that means it's a negative charge lah. While for the positive type silicon, they're referring to the free hole. So that means it's a positive charge for this case lah. Okay, so when sunlight hitting the surface of the cell, okay, so the photovoltaic effect occurs. So the photovoltaic effect is actually what? So the ray of the photon in the sunlight strike the surface of the silicon semiconductor material will be vibrating or releasing the free electron from the material. Okay, so that means there is a electron traveling through the circuit from one layer to another layer here. Okay, so here got many layers, right? So there is a flow of the electron. That means the electricity will be produced lah. Okay, so here we have the how the solar actually works here. So when sunlight hit the solar panel, as mentioned just now, the photon will be converted to electron. So when we have the flow of electron, the electricity is generated. But the electric generator is in type of direct current. Okay, so for the home appliance, normally we're using AC current. So we need to have an inventor to convert the DC current to AC current so that our home appliance can use the electricity where generated directly from sunlight. Okay, so photovoltaic cell can be combined to form solar panel. It'll be like this lah. So the wiring solar photovoltaic panel can be either in series or in parallel or combination of both lah. So the arrangement of the solar panel at solar cell charging power station play an important role to providing suitable voltage and current. So that means arrangement of the solar panel in series and in the parallel will given the suitable voltage and current we needed in different application. Okay. Okay, so the next will be where to operate the panel depends on what purpose and what are the next device it can support. So here we discuss another technology which is well developed in America and China now. Okay. Okay, so nowadays electrical cars can be becoming more advanced and using battery packs to power the electric motor and to start the car engine. Okay, so here we discuss another type of the generation of electricity. So where from battery. So that means converting the chemical energy to electrical energy. Okay, for just now the solar panel we're using application of the transform of solar energy to electrical energy. Okay, so the common use of battery are lithium ion or nickel MH battery here. Okay, so the battery volt range required is 300 to 800 volt. So that means the numbers of the battery we need to use and the arrangement in series or parallel also have to calculate here. Okay, so in this figure you can see to power electric vehicles, we actually need 1,000 of battery. Okay. Okay, so when the electrical energy is used up, the battery can be recharged with an electricity grid. So this is you can see actually here is the recharging process for the electrical motor vehicles lah. Okay, not in our common petrol station. Okay, here is actually charging the electric vehicles. Okay, so these battery pack are durable, so normally can last for long time, okay? Maybe about 8 hours, okay? Can provide high current for the car for function optimally. Okay, so you can see now the invention of the car, there is not only using the battery packs only. They have already invent the solar energy together with the battery in the new invention of the car. Okay, so the use of the electrical vehicles is a good alternative in maintaining environment sustainability. Okay, so that's all for my sharing today. Okay, thank you. So I pass back to Bangkok.
Okey, terima kasih daripada Mr. P. Okey, tahniah dan juga terima kasih ucapkan kepada semua yang setia mengikut kelas pada petang ni. Okey, sebelum kita nak tamatkan dengan sesi siaran langsung hari ini, mohon tutupkan ruangan chat, klik butang subscribe dan juga aktifkan ikon loceng supaya kamu tidak akan terlepas dengan sesi kelas Mr. P yang seterusnya. Okey, sila klik like dan juga share link kelas kita hari ini kepada rakan-rakan dan juga media sosial anda. Okey, jangan lupa ikut kelas-kelas fizik seterusnya pada hari Jumaat 9.30 malam untuk tingkatan 4 dan juga Ahad pukul 2 petang untuk tingkatan 5. Okey, layani portal www.academyyoutuber.com untuk mendapat info yang terkini berkaitan kelas tuition AYU percuma. Okey, kongsikanlah kepada rakan-rakan dan juga guru di seluruh Malaysia. Okey, link sijil, rekod kredit pelajar serta username Mr. P juga akan diletakkan pada ruangan chat. Sila ambil perhatian, link tersebut akan tamat tempoh setengah jam selepas live ini ya. Okey, pastikan anda login dengan guna email e.d.g.e, email MOE, email My Guru dan juga email Javi untuk membukakan link perkenaan. Okey, sebelum cikgu nak tamatkan kelas pada petang ni, okey, kami merasa banggalah kerana Mr. P dah share banyak info tentang solar system dan juga yang macam mana kereta guna elektrik. Ini ialah semua teknologi yang baru yang akan datang. Mungkin Malaysia pun ada, semua akan guna. So ini merupakan sesuatu knowledge lah yang baru kami boleh belajar. Okey, saya mempersilakan Mr. P, ada apa nak beri, nak tambah lagi untuk belajar kita?
Okay, so terima kasih. Okay, Cikgu Kok. So sebenarnya saya susun subtitle ini, saya perlu perasan sebenarnya untuk new syllabus, dia sudah banyak tambahkan teknologi yang baru, iaitu termasuk solar cell dan juga electric vehicle lah. Okay, so sebenarnya ini telah sangat-sangat maju di negara Amerika dan juga China. So saya harap para pelajar boleh expose more information kepada ini supaya anda boleh naikkan taraf kemajuan teknologi di Malaysia.
Okey, terima kasih Mr. P. Okey, Cikgu Hasnita ada apa nak tambah lagi?
Okey, terima kasih Cikgu Kok. Okey, Assalamualaikum dan selamat petang semua. Congratulations Mr. P. Bagi saya satu penjelasan yang sangat clear lah dan contoh-contoh yang mudah difahami. Macam Cikgu Kok dan Mr. P kata, bila kita belajar fizik ni, kita belajar juga teknologi dan diharap-harap pelajar yang belajar fizik ni di masa hadapan lah mungkin akan menjadi inventor yang baru, memperkenalkan teknologi-teknologi yang baru di negara kita. Kita akan rasa banggalah kalau ada inventor yang baru yang datang dari Malaysia. Kita boleh fight dengan inventor daripada negara-negara lain. Jadi anda belajar bukan sekadar untuk menduduki peperiksaan sebenarnya, tapi anda manfaatkanlah ilmu di sebalik apa yang anda pelajari itu supaya di masa akan datang anda dapat aplikasikan semua ilmu yang anda telah kutip selama anda berada di sekolah. Jadi harapan cikgu, rajin-rajinlah belajar. Selain itu jaga diri baik-baik ya. Kita masih lagi diancam dengan COVID dan meningkat semula ya Cikgu Kok. Dan betul. Satu lagi selain itu kita juga ada influenza sekarang yang sangat banyak menular dalam kalangan pelajar-pelajar sekolah khususnya. Jadi anak-anak jaga diri baik-baik, belajar rajin-rajin, semoga berjaya semuanya. Okey, itu saja Cikgu Kok.
Okey, terima kasih Cikgu Hasnita. Okey, akhirnya Cikgu nak bagi kod yang terakhir untuk hari ini punya, iaitu nombor 96. 96. Okey, so terima kasih kepada semua penyokong Akademi YouTuber. Sekian daripada kami, salam hormat dan jumpa lagi. Bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.